Hey everybody, Mr. Keeney again. Today we're going to do our section 1.3 day 2 notes, which is going to be about the distance formula. As a reminder, we are in Unit 1 and we are still developing our foundations of geometry using our undefined terms, point, line, and plane, and the vocabulary that we've gone throughout the unit up to now. The I can statement, as you can imagine, is I can find lengths of segments using the distance formula. So the first thing, as you can probably guess, is we're going to be talking about the distance formula. And over here what you'll see is, one, the definition, or we need to fill out the definition, and then two, a little picture. So I'm going to use the picture to kind of help explain what exactly is going on. So the first thing it says is if A and B are points in a coordinate plane, and the points they're talking about is A is right here, B is right here. If those two are points, and we want to find the distance, so they're talking about this distance between them, then we have a formula for that. And I want to really talk about what the formula actually does. So I'm going to get another color here. What it does is it takes the horizontal distance, if you will, so the x2 minus x1, that horizontal distance between A and B, and it takes the vertical distance between A and B. And really what it does is it really applies something called the Pythagorean theorem. If you've heard of right triangles and the Pythagorean theorem, you would know that a squared plus b squared equals c squared. Now this isn't exactly what the distance formula will do, but it is derived from that. So I just wanted to give you that little background knowledge that when you see this here, it is going to be based off that formula. And here's what the formula says. So if I want to find the distance from A to B, I'm going to take the square root of the x2 term minus the x1 term squared. And before I move on, that is just right here, the horizontal distance. So when I look at this, it's just the horizontal distance squared, just like it would be a squared plus b squared. So here is the plus b squared, which is y2 minus y1 squared. And that is actually it. And before we move on, that right there is the vertical distance between the two. So that is the distance formula. We are squaring the horizontal distance and the vertical distance between the 2 points, and then we're square rooting the whole thing, which is, again, we are getting from the Pythagorean theorem. This formula right here, and by this formula I mean this guy right here, will be supplied to you. I just want to make sure that you guys are able to use it, that you guys are able to apply the distance formula. So we have a couple of examples here. Example 1, what is the approximate length of RT with endpoints R32 and T negative 43. We have a nice picture over here. The very first thing I want you guys to do with these problems is label your points. Just like we did with the midpoint formula, I want you to come up here and say, okay, that is x1, y1, because that's my first point. So my first x, my first y. This is my second x, so x2, and my second y, y2. And what we're going to do is we're going to use that distance formula that we just learned about. So we're finding the distance from R to T, and what we learned was that is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And what we're going to do now is just substitute values. And by substitute values, like instead of x2, I see x2 right here, it's negative 4. Instead of x1, I'm going to put 3 in for it. So let's go ahead and do that now. So we have, instead of x2, we said negative 4 minus, instead of x1, we have 3 squared plus, instead of the y2 and y1, if I'm looking for y2, I know y2 is right here, it's 3. If I want y1, I know y1 is 2. So that would be 3 minus 2 squared. So RT is equal to, and now we simplify. So inside the parentheses for this first one, I'm thinking, what is negative 4 minus 3? That is negative 7 squared plus 3 minus 2 is 1 squared. And so we get RT is equal to the square root, and then negative 7 squared is 49, and 1 squared is 1. We're going to simplify again. So with this, 49 plus 1 is the square root of 50. And you'll hear maybe some clinks and stuff in the background because I'm getting my calculator out right now, and probably you should too. And I'm doing the square root of 50 in my calculator. So we're going to get a decimal point. So these squiggly equal sign I did means approximately. And the square root of 50, and we're going to use 2 decimal places. So 7.07, and then we're going to say units because we're talking about distance. So 7.07 units. That is using the distance formula to find the distance from R to T. All right, we got another one here, example 2, and I'm going to go ahead and get the distance formula written out. I'll change colors. Let's do it green. So it wants GH, distance from GH is equal to x2 minus x1 squared plus y2 minus y1 squared. And when you're doing these problems on your own, whether it's trying them out before me, whether it's in your practice problems, make sure to have that formula handy because that's something that you're going to be able to use. And instead of, I need to label. Instead of using x1 and x2, x1, x2, and instead of y1 and y2, I'm using those. So again, my first point here, I got my first x, my first y. So that's why it's x1, y1. And then my second point, second x, second y. So that's why I'm using x2 and y2. And our next step is just to substitute in our known values now. So instead of x2, I look at x2, it is -3, minus, instead of x1, I label that to be 5, and then squared, plus, instead of y2, I label that to be 6, minus y1, which is -1. All right, now that I have substituted values into my formula, it is all about just simplifying. So for that first one, first inside the parentheses, -3 minus 5 is -8 squared plus 6 minus -1. So that's going to turn it into a positive. So 6 plus 1 is going to be 7. It took me a while. So 7 squared. And then I'm going to go ahead and square those things. So -8 squared is 64, and 7 squared is 49. And I'm going to do something here too. Well, I'm going to combine like terms, but I'm going to go ahead and check my calculator. If you're ever not sure, use that calculator. So 64 plus 49 is 113. And once we're here, I'm going to go ahead and put it to calculator. I'm pretty sure we're going to get a decimal again. So 113, I take the square root of it. Oop, I went one too far. You can't see my calculator screen, but I did something wrong. And I'm getting about 10.63 units. All right, and that would be my final answer here. So 2 examples for you, and again, I post these notes up on Schoology, so take a look. You'll always have them. And then the final one here, find the length of the segment, then find the coordinate of the midpoint of the segment. So we got 2 things. They want the length, so that's distance, and they want the midpoint. So this is kind of going back to, we're not going to use the distance formula. We're going to use kind of the definition of distance, the absolute value. So I know with those 2 points, if I take the difference between 6 and I subtract the second value, so actually let me go back here. If I take, let's call this x, or this would be our first one, x1 and x2. If I can get x1 minus, x2 minus x1, I can't talk right now, then I'm going to get this distance. But I want the absolute value, meaning positive, because I'm never going to have a negative distance. I can't drive negative 300 miles. It's not possible to go negative. So I'm going to substitute in these values. So instead of x2, I had 6 minus, and x1 is -3. And if I do 6 minus -3, again, a minus and negative makes a positive, and I'll get 9. If you want to check your work, you can just count these ones. 1, 2, 3, 4, 5, 6, 7, 8, and 9, which is exactly what we got down here. So for the distance of the segment, I went too far. The distance is 9 units. So 9 units is our distance. And then what we want to get to find the midpoint, I'm going to do x2 plus x1, and I want the average. I want the middle, so I'm going to divide it by 2. x2 is 6 plus x1 is -3 divided by 2, and then 6 plus negative 3. This right here is like minus, plus a negative is like subtracting. So I'll get 3 over 2, which if I were to divide that, that is 1.5. So our midpoint, if we were going to go to 1.5 right here, moving the board, that would be our midpoint. All right, so that is our final example. All right, so if you have any questions about this, you know how to reach me, and we'll be speaking about this more